This is Algebra 2, 2.8, Graphing Linear and Absolute Value Inequalities. This is the last lesson in this section. Most of it's review from Algebra 1. The only new part will be the absolute value part at the end. Remember that a less than or greater than sign is a dashed line, a less than or equal to or greater than or equal to is a solid line, and that you always shade the true side. So our first problem that we're going to graph is 3x plus 1/2 y is less than 2. So always remember to be able to graph these, especially the linear ones, they have to be in slope-intercept form. So we want to subtract that 3x over. So you have 1/2 y is less than negative 3x plus 2. And then since they're multiplying by a half, I'm going to divide by a half. And so y is less than negative 6x plus 4. And so let's go to our line, our coordinate grid. And so the first thing it says is that it crosses at positive 4, and it has a slope of negative 6, so we go down 6 and over 1. I don't know about your graph if you can go down more. Now if you look, our sign tells us, right there, it's a less than sign, so we know that it's going to be a dashed line. So if you remember back from Algebra 1, the test point that we like to use to determine our shading is 0, 0. So if we go black and we plug in 0, 0, so you can plug in 0 for x, 0 for y, and I would just do it to your original one. So we have 3 times 0 plus 1/2 times 0 is less than 2. So 3 times 0 is 0 plus 1/2 times 0 is 0. So you have 0 is less than 2. Well, then you ask yourself, is that true or false? In this case, it's true. So you go over to your graph, you find 0, 0. This point's true, so that's the side of the graph you're shading. You can get as creative with your shading as you want. You can use colored pencils, you can use your pencil or marker. Now the only thing is, if you use a colored pencil or marker and it's wrong that you shaded on, it's going to be hard to erase and do the new one. Okay, let's do one more linear. So it says graph negative x plus 2y is greater than 4. Again, you've got to put that in slope-intercept form. So we're going to add the x. So 2y is greater than x plus 4. Divide by 2. And so y is greater than 1/2 x plus 2. So if we go to our graph, we put our first point at 2. We have a positive 1/2 slope, which means we go up 1 over 2. So up 1 over 2, up 1 over 2. And go the opposite direction now. Look at our sign. Our sign's a greater than sign, so it's going to be a dashed line again. We're going to use the point 0, 0 as our test point. The only time you cannot use 0, 0 is if your line is going through 0, 0. So plug it in for the top part. So we have negative 0 plus 2 times 0 is greater than 4. So we have 0 is greater than 4. Well, 0 is not greater than 4, so that's a false statement. So if we go over to this side, this is where 0, 0 is at. This is false. So that means you have to shade the opposite side. Because if this side is false, then this side above it must be true. So that's the linear ones. Let's go to one that's an absolute value. So we have y is less than or equal to 2 absolute value of x plus 3. So remember with t-charts, we always want to, or with absolute value, you want to either make a t-chart or use your skills of absolute value functions to move the graph of the pair. Use your skills that you learned in parent functions to move it up or down according to what the equation says. So if you either type that into your graphing calculator or pick some points. So if we pick our normal points, -2, -1, 0, 1, and 2, and plug them in, excuse me. So if we plug in -2 for x, you get 2 times the absolute value of -2 plus 3, which gives us 7. If we plug in -1, we get 5. We plug in 0, we get 3. We plug in 1, we get 5. And we plug in 2, we get 7. So we found our turning point right there because it's the same on both sides. So let's go ahead and plot these. So we had -2, 7. We had -1, 5, 0, 3, 1, 5, 2, 7. So if you notice, the +3 on the outside moved our graph up 3. The 2 on the outside made it steeper. Remember, it stretched it vertically there. And so go back to your line. This is a less than or equal to, so it's going to be a solid line. So make sure we change that. Then we have to either pick a point to test that's either on the outside of the absolute value or on the inside. Well, 0, 0 is on the outside, so that's the one I would choose. So let's go back. Let's plug in 0 for y, 0 for x. And when I plug in 0, 2 times the absolute value of 0 is 0, and 0 plus 3 is 3. So it says that 0 is less than or equal to 3, which is true. 0 is less than 3. And so 0, 0 is true, so then we're shading all of the outside of the absolute value. Let's do one more of those. So here's what I want you to do. I'm going to write this problem down, and what I want you to do is pause the video and graph this, and then unpause it and make sure you did it correctly. So as you have already made your t-chart and everything, you know that the +1 on the inside moves it left 1. So if we do -2, -1, 0, 1, 2, the -2 is 3, the -1 is 0, 0 is 3, 1 is 6, and 2 is 9. And so we know our turning point's right here. So you might want to see what happens at -3 here. And -3 is 6. So you can see that it pairs up. So you know -4 will be 2. So go and plot your points down. Well, you should have already plotted your points. And so at -3 it was 6. At -2 it was 3. -1 it was 0. One, 3, or 0, 3, 1, 6. Yes, there we go. And we noticed that it was going to be a solid line on this one as well. Zero, 0 is our point that we're going to pick. So when we plug it in, we get 0 is greater than or equal to 3 times 0 plus 1. And if you notice, we've already plugged in 0, so we know that it's going to be 3. So it says 0 is greater than or equal to 3 on this one, which is false. 0 is not greater than or equal to 3. So this is where 0, 0 is at. This is false, so we're shading the inside. And this concludes our review unit.